All right, welcome back, everybody. Session four, 3 sessions in, and we are still showing up every single week. And I want to acknowledge that. That's not nothing. A lot of started groups start strong and fade. We haven't done that, so generally good on all of you guys for showing up and participating in this stuff with me. Um, a quick little pulse check before we get into it. How's everyone feeling coming out of last week? I know Zaya said she had you know, uh, some issues with her mock interview, and I know Zach. I'm sure he'll be antsy to talk a little bit about that with you. And I know like there he is. Well, I absolutely agree with that because I was applying to some jobs today, and one of the job applications it was like, you know, we don't care, the things that you say that you can do. We want to see what you have built, and we want you to be able to point to what you have done. And like so like that it is really good to just, keep practicing. And I forget who, someone famous I'm sure said it, but it's, if you want to be good at something, do it 10,000 times. That's practice makes perfect, and there's no easy way to it. It's just, we just got to keep practicing. I mean, like I fumbled around in my interview and, um, just I don't know how I mean, he thankfully was, happy with my answers, but it is very flustering. I was so flustered. So it's not just you. And that's just one type, and like, I know Zach and I, we've each had one, and some of the applications I was looking at today, it's the process that they will go about it is the first stage is a AI coding challenge, and then after that, then you'll have your HR interview. And it's just so crappy that you don't, some of these jobs, they aren't even willing to meet with you unless you're able to pass these tests. So it's silly, but eye trackers, share screen, all of it. Yeah, yeah. I just want to be able to do it. It's just nerve-wracking though. It's like, really, you're gonna. It's like it, well, it's like going to the grocery store. It's like they won't even hire grocery attendant anymore to check me out and bag it. I got to go to a machine, and some dude wants to check my receipt as I'm walking out. Like, bro, take my receipt. I'm walking out. I did my job. You know what I'm saying? It's just like it's just one of those things that they just yeah, it's silly. But yeah, no, tech interviews, they're gonna be hard, and I mean, it's practice makes perfect, and just practice, especially since your boyfriend who does backend engineering, do some role playing, do some mock interviews with him, do some leak code problems, or ask him to pull, like a leak code problem offline, and be like, hey, do you mind, like, walking me through like a mock interview and hitting me with a leak code problem, and let me try to whiteboard it out, and like, and that's it. You have a great tool right there. Yeah. See, but that's why I'm saying pull a leak code problem, because if you want to check how if he's being just nice or not, you can then plug that leak code problem in online on your phone or on your desktop, and then you can see if he was being nice or not. So, yeah, hey, that's why I said leak code. Yeah, leak code, LEET code. You can No, but you can find it in the App Store, and you can also do it online. There's also Code Wars. That one's kind of like a video. I, I like it. I like it. It's this. It's the same thing, just a different platform. I like Code Wars because if Triple Ten is still doing the way that the way they should be, um, like they told me, like in like the theory, it was like, okay, go to Code Wars and then put in like this code, and it shows all the triple 10 students. And so as you like answer questions and get them right, you get points, and the more points you get, you move up in the ranking system through all of the students. So it kind of creates like a little competitive like video game atmosphere almost. Like, obviously you're just there coding, but it's, you have a little bit more of a drive because you're like, I know these people, or I know, they're a part of the same program I'm in. Let me try to beat their scores. Oh, they're at 620. Well, what the heck? Clearly they're doing something right, and it starts getting the juices flowing and things like that. So I like leak code. I also like leak code because I do also like leak code because interviewers take more problems from leak code than they would from code wars. So doing both is proficient. Yeah, I mean, if they recommended them, definitely give them a try. I mean, drop them in the I haven't heard of those. I haven't heard of those, so drop them in the resource tab, later, and I'll definitely check those out as well. Okay. Yeah, that's fair. Fair, fair, fair. Well, alrighty. Well, then, let's get into today's material, and then we can finish up with some more of this stuff, and anything else that anyone else wants to bring up for today, just so the video isn't running too long. So last week we did APIs, REST, and state management. Um, so I definitely want to make sure that, these are some things that we keep in our head from last week because making requests, managing state is going to come back around tonight. Authorization doesn't exist in isolation. It sits on top of everything we've already been building. Tonight's topic is one that I think is think that has a specific kind of reputation. It sounds heavy. It sounds like something you need years of experience to understand. And I want to push back on that right now because, in my experience, especially with some of the projects that I've done, authorization is one of those things where the confusion almost entirely comes from nomenclature. Um, Once you have the vocabulary and the mental model, it unknots really quickly. So we're just going to kind of go through all that tonight. So authentication and security. Yeah. We'll start with framing authorization as a concept. Um, we'll start with the single most important distinction in this entire topic because it gets collapsed down all the time and will trip you up in interviews if it's not very clear. Authentication and authorization, everyone says, those two words, are very similar. They start with the same letters. They're interchangeable to most people that don't really know better. But they're absolutely not the same thing. Authentication is who are you? And prove it. Authorization, okay, I know who you are, but are you allowed to do this? Um, you get authentication once when you log in. You get authorization constantly. Every time you try to access a resource, hit a route, take an action. These are different checks happening at different points in the flow. Think about a concert venue. When you show your ID at the door, that's authentication. The bouncer is verifying who you are, who you say you are. When you try to get into the VIP section and someone checks if your wristband is gold, that's authorization. You're already inside. This is just permissions checks. Um, can any of y'all think of a place in a web app where those two things would happen separately? Yeah, so just kind of talking like in terms of authorization and authentication. Like when you go to a concert, showing your ID at the door to the bouncer, that would be authentication. You know, But then if you try to get into VIP, them checking your wristband would be authorization. So like if you're in somewhere like on a web app, where would you typically see those two things happen? And I changed, yes. And so like right here, right here I also pulled it up on so you guys can see and take notes on it. But yeah, showing your ID at the door, authentication, getting stopped at the VIP rope authorization. So yeah, authentication would be the bouncer essentially. Yeah, you're showing your ID at the door. You're authenticating who you are. I am who I say I am. I'm authentic, you know? No, no. Yeah. Like if you wanted to kick me out of this Discord server right now, you wouldn't be able to because you don't have the authorization. You do have the authentication to come into this channel and to get in here, but there's only so many things you could do, right? Like you can't create a text channel, but you can post in that text channel, you know? Yeah, yeah, kind of. So the big thing to take away from it, the big thing to take away from it is so when you're showing the bouncer, it doesn't really matter. It's when you're showing your ID at the door, you're just saying like, "Hey, I am who I say I am." Like you're just saying, it's you're authenticating who you are. Yeah. Because technically what because you're seeing a different bouncer at when you're showing your wristband at the rope, but you're already inside. This is just a permission check now, so that's an authorization. Yeah, exactly. Yep, yep. If it was all you could drink, yeah, you're fine. You're fine. Don't apologize. That's what we're here for. Yeah, yeah. Like think of it like with that free account, right? you are you authenticate when you log in, so they already have your playlist and things like that. But if you did get premium, your account is now authorized to have essentially an ad blocker, so you're not getting ads on after every single song. Otherwise, because like I would assume the way that they're running it, and I don't know. Obviously, this is just me thinking as a coder. If they were to use React, they're going to use some sort of state management to dictate that, right? Like if paid, set authorization to, block ads or whatever, however they have it set up. But I would assume it would be out of state management though, which again returns directly back to last week and, you know, which sits on top of this. Um, let's see, you log in. So yeah, logging in, that would be auth, server checks, your credentials, verify your identity. Um, let's see, maybe your admin. some of this my notes I'm skipping because we cover a lot of it when we chat. Now, why does this matter for job searching? Because authorization, auth, as a keyword shows up in nearly every job listing that has any backend component. When an interviewer says, "Walk me through how you'd implement authorization or authentication," they're also implicitly expecting you to know when authorization comes into the picture. Knowing both keeps them distinct in table stakes. Before we go too much deeper, I want to talk about the landscape of how authorization actually gets handled in modern apps. There's three main paths. One, you build it yourself, full control, full responsibility. Two, you could, yes, for both of them, when to use them, and like how to handle the landscape through modern apps. Two, you could to build it yourself, full control, full responsibility. And then two, use a library, something like Passport.js. The heavy lifting is abstract, but you still use your own implementation. Let's see. Nope, that's the next one. And then three, you use a third-party provider, like Auth.0, Clerk, Firebase Auth, Supabase, um, which I might be using Supabase for my private app. Um, and then you hand off entirely authorization. You hand authentication off entirely and just plug in. So we're going to spend the tonight on the first two because you can't understand the third without understanding what it's doing for you, and it's kind of hard to show you what's doing for you if we're not actually using it. But like Auth.0 and that third party provider, that's going to be like when you're going to purchase, like your Icon or Snowboard Pass or whatever, and you want to use all these third party, vendors and things like that. They're using all of these different authorization checks, or even at like pizza shops, when you're paying through certain websites, most of the time it's not going straight through them. It's going through like a speed check third party authorization service before it shoots back to the actual individual. So it's used everywhere and all the time. It can be very messy and can be very slow. But one can also be messy. It just depends. Yes and no. I mean, there's people who hack things every day, Now, question for you though. So like some I'm actually curious about. Yes, we're learning authorization, authentication. Now there's, people that go into cybersecurity. Is this kind of where you would start kind of bringing them in, or are they more just designing the software that you would implement? Yeah, they keep testing. Yeah, you keep kind of playing back and forth, like, okay, here, this is what we got, and they're like, yeah, you thought wrong, fix it, and you just keep going back and forth. Or that's fair. Okay. we're gonna make that one of the videos for 1 week, not next week, but we're definitely gonna I'm gonna add that into I think that'd be a great topic to talk about, cybersecurity. Yeah, I can do some research and I got some friends. Yeah, so yeah, no, that I think that'd be a great topic. Oh yeah. How would you my notes just go? Here they are. Shot all the way down to the bottom. You silly goose. And sorry guys. Provider. Yeah, yeah, that's about it on authorization and authentication. So auth N and auth Z. Um, let's see. Next, we're gonna dive into JWTs, the deep dive. What's inside of a token. All right, so okay, so JSON Web Tokens, JWTs, pronounced JOTs, if you want to sound like you know what you're talking about in a meeting. Um, th there's a genuine tip that I guess jot is something that people do look out for and watch, their expression shift slightly. It can be funny. Some people use it, some don't. Just a little tech term. Um, Here's the thing about JWTs or JOTs. The most resources explained backwards. Uh, they explained they explain the format first and the purpose second. Um, and we're going to try to flip that. The problem with JWTs solve is this. HTTP is stateless. Every single request your front end makes to your back end is, from the server's perspective, a brand new conversation. The server has no memory of you, so once you log in, how does the server know on every subsequent request that you are still the same person who's logged in? And that's kind of the problem. JWTs are one answer to that problem. Um, the big picture flow is, a user would submit users submit credentials, the server verifies, server creates a token and then sends it back. The client stores it, the client sends it on every future request, and then the server reads the token to know who is asking. Um, Now, what is actually a token? A JWT has three parts, separated by dots. It's a base 64 encoded. It looks like gibberish when you first see it, but once you decode it, it kind of gets easier. You have a header, a payload, and a signature. Your header is typically going to be an algorithm used to sign the token, token type, not where it's not where the interesting stuff lives. Let me see. We're not at expire yet. The payload is the data. It contains claims, pieces of information about the user. Standard ones include like sub for subject, usually the user ID, IAT for issued at. Everyone knows the expiration one. You can also put custom claims in there, like users roles. And then finally, that's set the signature. This is the security mechanism. The server takes the header and payload, combines them, and runs them through a hashing function using a secret key that only the server knows. And that is the hash signature. Um, Now, question for the group, is the payload secret? Can anyone read it? So a JWT, so this token, right? It has three different parts. As the header, which is, the algorithm. or the token type, the payload, which will be your data of whatever you're sending, right? And then the signature is going to be the security mechanism that hashes it out. So it's specific and people can't read it really, right? So would the payload be a secret if in that instance? Could anyone read it? Yeah, you're absolutely right. No, the payload is base 64 encoded. It's not encrypted. Anyone who has the token can decode and read the payload. Um, this is a very common misconception. The signature doesn't hide the data; it just verifies the data hasn't been tampered with. So, so is the signature is the security mechanism. It's going to hash the data. It's not encrypted, however, it is base 64 encoded. Anyone who has the token can decode. The token decodes it. Um, yeah, it's a, a lot of it. So as you're reading through it, though, hopefully a lot more of it makes sense because reading through it fresh is just it is gibberish. But I feel like having people at least talk about it makes it stick a little fresher. I feel it. Or that carousel's only spinning counterclockwise directions. Oh wait, what? Oh yeah, let's move on. I don't know, but those are the only ones I've ever seen. Anywho, let's see. But yes, so the signature doesn't hide the data. It verifies data hasn't been tampered with. If you wanted to write that part down too, that's a good part. Doesn't hide data. It verifies data hasn't yet. It verifies that it hasn't been tampered with because if it's been tampered with, then it won't match. And then that's also on the screen right here. Never store sensitive data in the payload. The signature proves it wasn't tampered with. It does not hide the data. No passwords, no PII. Sending you this? Yeah. Oh, how's that? Perfect. Yeah, I'm still learning. Perfect. Now we're zoomed in. I got you guys. Um, and yeah, and there's the first two just to show them, but there you go. So critical implication: never put sensitive information in a JWT payload. No passwords, no credit card data. The user's ID and their role, fine. Their social security number, absolutely not. Um, I'm not going to give you my social security number to begin with unless I get the job. So um, that's just something my mama always told me. That's just a safety thing. So when the client sends this token back to the server, what does the server do? It takes the header and the payload, reruns the signature algorithm with its secret key, and checks, does the signature match? If yes, this token hasn't been touched since it was created. I trust it. If no, reject it. Um, Now, expiration. Why do tokens expire? Let's see. Um, let's see. Here's a question. What's the security argument for giving a token a lifespan? Why would you want to give another way to say it? Why would you want this token to have a lifespan for security purposes? Okay. Yeah, pretty much. Yeah, tokens can get stolen. Yeah, it's yeah, because tokens can, yeah, because tokens can they can be stolen. Um, and they definitely can, and you want the damage to be as time limited as possible. So like if there is a token available, you want it to be able to notice that, hey, when it refreshed, like, oh, this isn't the same data. This person probably shouldn't be here. We need to reject it. Um, or it's like, if you have a shopping cart up, right? And you leave your computer to go take care of something around the house, and your kid decides to run up and click submit on a $2,000 order that you did not want sent right then and there. If they were away from their computer for X amount of time, it's not going to push through because the token has expired. The same thing on a test. They want to make sure that someone isn't sitting there and trying to cheat on their online exam. They have a certain amount of time, otherwise that token refreshes and won't let them back in. So like if they click off of the screen, it could be a less than a 30-second or less than a 1 minute token time if they click off of screen, because that's probably a security protocol of, hey, they're probably trying to open up another browser to cheat right now, so we need to kick them off and flag this right now. Um, let's see. A token that lives forever is a skeleton key. A token that expires in 15 minutes means the attacker has a 15-minute window and not an infinite one. This leads to leads to the access token, refresh token pattern, which you will see everywhere. Short-lived access tokens, maybe 15 minutes to an hour. Long-lived refresh tokens, maybe 7 days. Um, when the access token expires, the client uses the refresh token to quietly get a new access token without making the user log in again. If the refresh token gets revoked server side, the user gets logged out. This is how log out all sessions features works. So where do you think we actually store a JWT on the client side? I'll give you guys a hint. It would either Do you think it would be locally or globally? Yeah. Yeah, there's two main options: local storage and cookies. Your local store, because when they're saying, hey, you should probably clear all of your cookies, those are all them tokens getting stored up in there. Um, Local storage is vulnerable to XSS, cyber attacks. Um, if an attacker can run JavaScript in your page, they can steal the token. Cookies with HTTP only flag can't be accessed by JavaScript at all, making them cross attack resistant. Um, but when you need HTTP only flag can't be accessed by JavaScript at all. making them XSS resistant, which would be but with those cookies that you do then need a CSRF protection. Um, no, it's I mean it's was it was it cyber was it stand for cyber security uh reference something? Yeah, rapid refresh, yeah. It essentially makes it so people can't like super refresh the site to try to bypass like to overload it with data to try to break through. Um, there's no really no perfect answer, and the I mean the right choice just depends on the threat model that you get that is presented for that problem. Yeah, never store a password. That's what we're moving. That's what we're moving to next. I just yeah, oh yeah, yeah we'll get yeah. um yeah, let's talk about passwords. We're gonna start this with a nightmare scenario because it's motivating in a way that's starting with best practices. It's motivating in a way that starting with best practices isn't. Um, Imagine you've built an app. The user signs up. You store their passwords in your database. Your database gets breached. An attacker now has a list of emails and passwords in plain text, and that is catastrophic. I mean, especially if you're promising users that their information is encrypted um, or safe. Not just for your app, but for every other service that those users have an account on. Because people reuse passwords, you have just become the weak link that compromised your users across the internet. So typically, when you have, when back in the day when you were getting a message saying like, "Oh, your this email or this password may be compromised," it's because someone probably fucked up on their side and they leaked it across to everything else. And because you reuse passwords, it is now compromised. This has happened, and it's happened to real companies with real consequences. Um, and it's not just a theoretical problem. I do remember Ashley Madison. That was one of the biggest ones that dropped. Husbands and wives finding out that their spouses were on there fucking and cheating and doing all this other nasty stuff because they got hacked and all of their emails and passwords were right up on there. So usernames, IDs, all of that got leaked and people were finding out the dirty. It was catastrophic to say the least. Do you guys remember any of those like that? Yeah, there's been a couple out there like Temu. Everyone that started using Temu when they first came out, a lot of credit card information got leaked. That's just another example right there. They were storing information that they shouldn't have been. Um, so pretty much, I'm not sure if I've ever heard anything about Venmo. But yeah, your first rule of thumb: never store a password. You should store a hash of a password. Excuse me. A hash function takes an input and produces a fixed length output. Um, it's deterministic. Same input always gets same output, but it's one way and you cannot reverse it. Given the hash, you cannot recover the original password. You can only verify by hashing a guess and comparing. So here's the problem with naive hashing. If you just run password 123 through, hashing, so SHA256, you'll get that same hash every time on any server for any user. Attackers have pre-computed tables of common passwords and their hashes called rainbow tables. They don't crack your hash, they just look it up. So that's why still making a customized password is still very proficient. That's why a lot of requirements when you're for authorization, before you're even allowed to generate an account or a password, they're like, that we want you to have at least this many capital letters, this many numbers, this many special characters, because they're trying to make sure it is as secure as possible. Um, and this is where we enter salting. Before you hash, go for it. Well, I guess it would just, hmm. I would have to say it would just depend on how you are encrypting. I mean, if you're hashing, it's taking your password and it's changing the structure of it. It's still the same length output. Like, I would say so. I mean, what do you think, Zach? How would you answer that? Uh, yeah, if you want to ask him the question. Let's. I mean, maybe let's get through the rest of this section on passwords, and maybe it will explain itself. Yeah, because with hashing, there's also salting, and there's a couple of different parts to it, and we're going to talk about, yeah, we'll talk about bicrypting. We're going to talk about the implementation in Node of in straightforward. So yeah, yeah, okay. Takes takes a hash function takes an input and provides a fixed length output. Fixed length output. Yeah, no problem. And then it's one way. You can't reverse it, and you can only verify by guessing and comparing. You can only verify by hashing. You can only verify by hashing a guess and comparing. So that's where the rainbow charts, the rainbow tables will come up because simple and stupid easy passwords like password 123, they have the same hash every time on every server for every user. So the rainbow tables, they don't need to know what the password is. They just look up the hash and they're able to crack it. Keep, it's where someone would keep a list of common passwords that have been hashed. So when they go and look at it, of course they won't know what that password is, but they can look up that hash that's in there, and if it's a common password, it will show up on their rainbow table and they can break the password. So that no, you're fine. No, I have a lot of this written as like a script, so please stop me to re-explain it so I can break it down slower if you need to. It's not a problem. Um, no, not at all. Not a problem. Yeah, and yeah, so that's why like a lot of sites they don't like you can't just type in password 123 anymore. They're like they require a capital letter. They require some numbers, some special characters, this or that. And if not, then that's probably a site that will get broken and they will leak all of your shit. Oh yeah. So enter salting. Before you hash, you generate a random string, the salt, and append it to the password before hashing. So now password 123 plus some random string hashes to something completely unique. Two users with the same password will have different hashes. Rainbow tables become useless. So because of the use of salt, we don't need to worry as much about rainbow tables. Um, so why is bcrypt recommended over just doing SHA 256 with a salt yourself? And that one would be more for Zach. That's a hard one, I know. So, two reasons. One, bcrypt generates and handles the salt for you. Two, bcrypt is intentionally slow. So it has a cost factor you can tune. SHA 256 is designed to be fast. For passwords, fast is vulnerability. It means an attacker with a GPU can make billions of guesses per second, um, like mine. But bcrypt forces each hash to take meaningful time. The difference between all passwords compromised in minutes and might take years. Uh, the implementation in Node is actually straightforward. bcrypt.hash, password, salt route, right here. Um, that's what yeah, this is what you're about to start learning as well. So this is what they're going to teach you. This is what they taught us. Um, mhm, to hash on registrations. And then bcrypt compare would be like attempt and stored hash to log in, and that's it. So essentially, if an interviewer asks you, how do you store passwords securely? The answer is, I hash them using bcrypt with an appropriate cost factor. Bcrypt handles salting automatically. I never store or log the plain text password at any point, period. So essentially, if you can take this table and just work it backwards, I'll bcrypt the password and hash it because it automatically generates salt. It's intentionally slow, so any attempt will take meaningful thought, and I'll never input a plain text. Period. With an appropriate cost factor. You'll hash using a bcrypt with an appropriate cost factor. B bcrypt automatically generates a random salt. It's auto generated through bcrypt. It's a bcrypt thing. I can type it to you. Um, so that would only be so let's move on to OAuth flow so we can kick through this because that's 5, 6, 7. So yeah, I have 7 topics and we're on 5. So OAuth flows. OAuth. Let's see. Next page. Delegated auth flow. There we go. Um, you have used OAuth many times, or you just might not have called it that. Every time you've clicked sign in with Google, continue with GitHub, log in with Discord, that's OAuth. There's an app that I'm trying to build right now, or that I'm currently building. It's using Discord OAuth in its authorization flow. So that's one that I'm currently like working with, and it's not as hard as I thought it would be, but it's still something I'm trying to learn more deeply. The core idea of OAuth is delegation, though. Instead of trusting your app with a user's credentials, OAuth says the user goes to Google, proves their identity to Google, and Google gives the app a token, confirming it. Your app never sees the password. Google just does the hard part. Um, a good analogy here, since my group likes analogies, I do too. It's like a hotel key card. When you check in, the hotel doesn't give you a master key. They give you a card that works on your specific room for the duration of your stay. The hotel manages the real security. You just have a scoped, time-limited credential. Now we're going to walk through an actual flow using Google as the example. Step 1, your app redirects the user to Google's OAuth endpoint. You include your client ID, the scopes you want, and a redirect URL. Step 2, the user authenticates with Google and proves your app requested permissions. The consent screen you've seen 1,000 times. Step 3, Google redirects the user back to your redirect URI and with a short-lived authorization code in the URL. And step 4, the server takes that code and makes a server-to-server request back to Google, exchanging the code for an access token. This exchange happens server-side, not in the browser. And finally, step 5, you can use that access token to make requests to Google APIs, like getting their profile information to create or match an account in your own system. Um, why does step 4 happen on the server and not on the browser side. Yeah. Yeah, because the token exchange requires your client secret. A credential that should never be exposed to the browser. Server-side code is not visible to users. Browser-side code is. That is the distinction. So server-side, not visible to users. Browser-side code is. So we want to make sure that the important things are not being seen, which would stay on server-side. Um, Now, why don't you roll your own auth? Um, because the fail because the failure modes are invisible. A broken UI is obvious. A broken auth can easily be and silently be exploited for months without you knowing. Unless you are specifically building security infrastructure, your time is better spent on your product. But use a library doesn't mean don't understand it. A misconfiguration authorization library is just as dangerous as a bad custom implementation. So always understanding what kind of library you're using is very important. Let's see. Route protection and authorization state. This would be authorization. I'll do the final one. Perfect. Um, on the back end, route protection means writing middleware that runs before your route handlers. Before your controller does anything, this middleware intercepts the request, reads the token from the authorization header, verifies it, and either attacks, attaches the user to the request object and calls next, or sends a 401 unauthorized and stops the chain. Common express pattern. You write an authorization middleware, then pass it to routes that need protection. Router.get, like profile, authorization, get profile. Um, routes don't get protect, like login and register. Um, those don't get middleware either. So only what needs guarding is guarded. Like you don't need once you're inside, you don't need to guard the user's description if they're already inside of the editing profile. Um, Anything you'd like to add on that, Zach? On the front end, the equivalent is protected routes. In React, with React Router, you can create a component that wraps a route and checks authorization state. If the user is authenticated, render that route. If not, redirect the login. Um, I'm using a protected route component pattern in both my Warhone app that I'm using the Discord authorization and the WTWR app that you guys will be designing through Triple Ten, the What to Wear app. Um, so definitely nice. Hell yeah! So did you just use some of that? Hell yeah! Um, Protected routes and all that. Yeah. Oh yeah. Um, Authors. Hell yeah! I love seeing that you guys are making it through the program. There's so many people that like I met through these classes that they talked such a big game, but they only made it past the first three sprints. So saying people actually make it through like really makes me happy. Uh, 95% of the learning through that boot camp is when you're doing the project, not when you're actually learning the theory, which is really counterintuitive when you're trying to earn a decent grade on a project for things that you're trying to practice. So if they are listening, the only thing I'd say is please add some more application practice. That would be cool. I didn't have that issue, so I feel bad for you. It happened all after I got enrolled, so they change it and they get you all. Yeah, yeah, yeah. Uh, fair enough, fair enough. And then just to finish up the authorization, auth state on the front end is a React state management question. Where does is this user logged in live? Options like local component state, context API. Like last week, this is some stuff we were talking about last week. So stand, Redux. The important things, it's persistent um, appropriately across navigation. Initializes correctly on app load by checking for an existing token and clears correctly on logout. Getting the logout wrong is more common than you'd think. Clearing the state, but not the stored token, means a page refreshed re-authenticates the user. So, someone, your little brother walking in behind you, refreshing the page, they could destroy all of your gaming material. I would lose my mind. um, it's, so like what would happen on upload in terms of authorization? What do you guys, what do you think? Yeah, I mean it's depending, right? It would depend on that token's lifespan in that instance. Um, so like the app would load and then it checks for the token in the local storage or cookies. If there's a token, it verifies it. And of course, like so when it goes to verify, one of the things that's verifying is, hey, what is the lifespan of this token, right? Like coming back to here, why tokens expire. Yeah, like if it's a short-lived access token or if it's long-lived, really depends on that refresh, right? Because right here, the access token, this is more so like if someone did refresh the page, they wouldn't be able to access again. Whereas this is if someone refreshes the page, they're still able to keep everything logged in, if that helps. Um, and then and then yeah, if there's a token, it verifies it either by decoding and checking the expiry client side. So again, yeah, checking the expiry, or by making a request to the /me or /verify endpoint. If valid, set authenticated state and populate the user object. If not, clear the token and treat as logged out. Um, that initialization logic usually lives in use effect at the top of your app. React has a lot of really great built-in methods like use effect and use state. And use date, and there's a couple of other ones. I mean, they're just really awesome. I mean, once you start using React more, it becomes an eye opener. It really has for me at least. With that being said, just going to do a quick recap before I open the floor to anything else you guys would like to chat about today. Authentication is proving identity, so auth n. Authorization, auth z, is checking permissions. Always separate these in your mental model. JWTs, JWTs, are stateless tokens with a verifiable signature. Payloads are readable by anybody, so never put sensitive data in it. Expiry and refresh, and the refresh token pattern exists to limit the blast radius of a stolen token. Passwords should be hashed with bcrypt because it slows down the design, salted automatically. OAuth delegates authentication, auth n, to a trusted provider so your app never handles credentials directly, which saves a lot on the security side. On the implementation side, backend middleware and front-end protected routes are the mechanisms that actually enforce all of this at runtime. That's the shape of auth. You will see every single one of these in real code bases. Um, Besides that, next week I was possibly thinking about doing something with like maybe databases, schema design, relationships, ORMs, querying. But with everything that's been posted in the channel, I'm obviously going to read through that. I'm going to plan something out that hits everybody's topics. I know Haru put in like 8 different suggestions. I know we just thought about cybersecurity and software engineering. I know Zaya, you'd like to cover some more technical interview material. And so I'd love to be able to do a little mix of everything. As well as get you guys a bunch of resources next week when I get in here to help with every aspect of that. So whether it's, different types of programs like LeetCode or, just materials that you can go like to watch videos or things like that, I'll see what I can do. Um, and as always, please keep making sure that you guys are, tossing some ideas and suggestions in there. Session notes are already up, at least the mermaid sheets. If you'd like, I can also drop this in here, because this is just very quick with it. Yeah, absolutely. But hey, we're 4 sessions in and we're building something real here, guys. I'm excited for next week, Other than that, that's all I got officially for the video. So, I mean, what else, anything else you guys would like to, discuss? So Jot was just the tech way of saying JWT. It's a way to maybe get, a look of approval or ha 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 from, your interviewer of, oh, I know tech terms. Yeah, oh, and so instead of saying like JWT, the Jot token, or the Jot access, Jot payload, Jot C, whatever it may be. Yeah, JWT. Yeah. So the J is JSON, all capital letters, and then WWT token. But some people call it JOT, JOT. But JOT is not a real thing. It's a JWT. Yes. Let's see. Fair. I learned Java in high school. Oh, No, no, not at all. I learned Java in high school. High school. So you can only imagine what we were doing with that word right there. Yeah, like it was, yeah, we were just being idiots. Yeah, so trust. I would never judge. Boobleen. Yeah, yeah, just yeah, different piece of it. And then um, and then here. Thank you guys for watching the video. You guys have a great day. I'm gonna end the recording. I'll see you guys in the next one.